The answer is simple. I can take two value. I can take x1 and x2 two value from the domain R. Since this is a real valued function, so its domain will be R. And we consider the fact that x1 and x2 are not equal. If x1 and x2 are not equal, then we can simply say that x1 cube, this value shouldn't be equal to x2 cube. If this happens, then also x1 cube minus 1, this value shouldn't be equal to x2 cube minus 1. Now what is x1 cube minus 1? x1 cube minus 1 is nothing but f of x1. And what is x2? x2 cube minus 1, it is f of x2. So we can clearly see that if x1 and x2 are not equal, we can easily prove that f of x1 is not equal to f of x2. So I can say that f is injective. Okay, so f is injective here. uh Everyone clear till this part?
Sir, injective, any other name? It's like one you're onto. Which one is we can say here?
You can say 1 1. Injective is
One.
1 1,
Okay.
and surjective is on 2. So
Okay.
basically we have checked for injective. Oh, so majority of you are familiar with the term 1 1 and on 2, right? Not that much familiar with injective surjective. Okay, okay, I got it. So second one I will check for on 2. Okay, on 2, or you can say as surjective. Now how to check for a function which is surjective or not? In order to check for surjective, what does surjective mean? Surjective means basically if we take any element from its codomain, I can show that, if I can show that that particular element has a preimage, then I can say that the given function is surjective. Okay, and there is one more technique. If I can show that my codomain set is actually coinciding with the range set, if if I can show this, then also I can say that the given function is surjective. There are two kind of techniques, but I will use the first one. So I will be considering an arbitrary element from the codomain of the given function. Let y be an arbitrary element from the set of real number. Here is its codomain. Okay, so if this function has to be surjective, then I have to have some x for which this should be happening. That is, y should be equal to some x cube minus 1. Now I will express x in terms of y. So if I just move minus from 1 from right to left, I will get x cube equals to y plus 1, and ultimately the value of x will be y plus 1 to the power 1 by 3. Now just simply tell me, uh, what are the values of y for which this particular equation holds? Or in simple sense, what are the values of y for which the value of x is undefined? Is there any kind of point for which for particular value of y for which we can't find a value of x?
I think zero.
Anywhere. You are telling me 0. If I take 0 plus 1 to the power 1 by 3, obviously it's 1. So basically I can see that for if I take y equals to 0 also, I can actually get a finite value. Do you want to try with negative numbers?
या माइनस में अगर हम जाएं, if we go minus values,
या अगर आप माइनस वैल्यू में भी जाओगे तो स्टिल इट्स डिफाइंड. I can show you. Let's
Okay.
take, let me give you an example. You will understand. uh, just let me think. Let's take y equals to minus 28. I am taking this as an example. Okay, minus
Okay.
28. Then what is y plus 1? Y plus 1 will be minus 27.
Hmm.
Now y plus 1 to the power 1
1 by
by
3.
3. This will be minus 27 to the power 1 by 3.
Okay. Huh.
Now what is minus 27? I can write it as minus 3 into minus 3 into minus 3
Hmm.
to the power 1 by 3. So the ultimate answer will be minus 3. So it's also
So
defined for my negative numbers.
पॉजिटिव पे भी होगा, नेगेटिव पे भी होगा, जीरो पे भी होगा,
सब पे
डिफाइन
होगा.
हो जाए।
सब
तो
पे
फिर
होगा.
क्वेश्चन क्यों पूछ रहे हैं कि किस पे होगा?
That's why I was asking. Agar consider the fact that instead of here I am having 1 by 2,
हम्म।
then is it defined for all negative values?
आई थिंक
Tell me.
इवन और का कोई सीन तो नहीं है कि इवन होगा तो डिफाइन होगा।
Yes, there is a scene. There is a
ओके।
scene. If this value had been even, if
हम्म।
the value had been even, then I can easily say that the particular function is not defined for negative real values,
हाँ।
because
ओके।
there is no number whose square gives me a negative number.
हाँ, वो ऑलवेज पॉजिटिव होते हैं अगर
Ah,
इवन स्क्वायर्स होंगे
yes.
तो।
Since it
हम्म।
is odd, that's why I can easily say that it's defined. That's why I was trying to convince you people that it's actually defined for all values of real number. Got it?
हम्म।
So basically, we can't find any y for which the value of x is undefined. So in that way, we can say that the function is surjective, because each and for each and every y, if I pick, I can get a x which is nothing but y plus 1 to the power 1 by 3. I can get a x which is y plus 1 to the power 1 by 3, such that f of y plus 1 to the power 1 by 3, this value will always give me y. No matter what value of y I take, y is
हम्म।
defined for all real numbers.
यस।
Got the point?
गॉट इट।
Okay. So that's why when we say that this function is injective as well as onto, so it's a surjective function. So what is the inverse function? The inverse function is generally denoted by f inverse, and it is written from, since it is a real valued function, and I have actually seen that it's defined for all real number. So it's a R2R function, and the inverse function is defined as like this: x plus 1 to the power 1 by 3. This is my inverse function here. And according to this given question, we have to find that what is the domain of inverse function. And now only you have seen that the domain is actually nothing but the entire set of real number. So in this case, the answer will be R. Just tell me if you have something doubt, any kind of doubt till now. Anyone? Just give me a thumbs up, so I can move for the next problem. Okay. Okay. Now moving on to the third question. Here we have a multiple select question. Okay. Let me do one thing. Let me just copy this question to bigger space, because it's actually getting a little bit problematic for me to manage space here. Okay. Okay. Is it visible, right? The question. Okay, moving on from the first part, it's given 0 less than b less than 1. I have a real number which is lying between 0 and 1, and another number I have x which is also lying between 0 and 1. I have to see if log x base b is less than 0 or not. I have to check. So how I can check? So if b is lying between 0 and 1, can you tell me what is the range in which log b is lying? Log, I am considering log base 10 here. Okay. So I can write it as minus infinity less log b less 0. Can I write this from this part to this part? Obviously, if you people have seen the graph of log, basically the curve of log is something like this, and it takes a
लॉग
value.
वन की वैल्यू कितनी होती है? लॉग वन जीरो होता है,
हाँ, log 1 is 0.
तो इसलिए आपने और लॉग जीरो इन्फिनिटी.
Basically, when log, actually log 0 is undefined, you have to understand this. Log 0
ओके.
is undefined, but if you see the graph, you can see that as the value of x moves closer and closer to 0, the value
हम्म.
of log is becoming sufficiently negative. What do I mean by sufficiently negative? As if the curve is moving like this and becoming very negative, but it's actually getting closer to the line x equals to 0. It actually decreases drastically as moves closer to 0, but at point 0 it's undefined. So that's why I have written log b should be lying in the range of minus infinity to 0. Obviously, when b is lying in this particular range, then the value of log must be lying between minus infinity to 0.
यस.
Is it clear to everyone? If if not, then you can tell me. I can repeat. No issue.
Sir,
Oh,
I want to ask one thing. If I take both sides log, so log zero is minus infinity or log one is zero. So आपने.
log 1 is 0. Log 1 actually is 0. Log 1 is defined. Log 1 is 0. This is the point 1 comma 0. This is the point where the graph is actually cutting the x-axis. Okay,
हम्म.
but log 0, at the point 0 it's undefined, because you might have studied in week 5 or week 6, whichever, I don't know, that exponential function and logarithmic function are inverse function of one another. Both are inverse function of one another, anti operation, just like differentiation and integration is the opposite operation of differentiation, right? Just like that,
Yes.
logarithm and exponential are anti operation of each other.
Okay.
And uh, we can easily see that if we draw an exponential function graph, the graph will be either something like this. The exponential value can never be negative, even not 0. And since I
Always
have
positive.
told you that logarithm and exponential are inverse operation to each other, so the domain of one is a range for one, and the range for one is the domain for one. Both are interchangeable. Something which is domain for log is actually range for exponential, and something which is range for exponential, it is actually domain for log. We can easily see that the exponential have a range from 0 to infinity. Even it's actually open 0 to open infinity. That's why log, when we define log, we don't have the point 0, because log is never defined at the point 0. It's out of its domain of definition. but but in a limiting sense, we can see that as my value of x move closer and closer to 0, the value of log x will become sufficiently negative, sufficiently so much negative that something you can't even imagine. That's why we are writing it to be as minus infinity.
Okay.
Infinity is a concept. It's not a number.
Okay. Okay.
Okay. So I hope it's clear for everyone now. Now, in same logic, I can write minus infinity less log x less 0. If I can write this for b, I can write this for x also, because the relations are almost same. Almost not. Everything is same. This step is clear now for everyone. Uh, what about others? If you people have any kind of problem, please tell me. Okay, okay, okay. So, so the idea is simple. I got two equation. One is giving me that log b is basically negative and log x is basically negative. I am actually not even interested in minus infinity also. I can simplify this equation and write log b is basically less than 0 and a log x is also less than 0. Now just tell me, I have two numbers. Okay, one is 3 and one is 1. Clearly 3 is greater than 1, right? Now if I multiply both side with minus 1, I will get minus 3, I will get minus 1. Now tell me, which one is greater, minus 3 or minus 1? Obviously minus 1. So
-1.
one thing from here I can see that when we multiply any positive number or any number with a quantity which has a different kind of sign, the sign of inequality changes. Initially it was greater, after multiplying it with minus 1, it's becoming smaller. So now just tell me, log x is less than 0. Now what will happen if I divide log x by log b? Log x is itself negative. I am dividing both side by a negative quantity. Now 0 if divided by log b, obviously it will give me 0. 0 divided by some finite quantity obviously gives me 0. Now since it's a number, when it's also divided by a negative quantity, what is division? Division actually means that multiplying by a reciprocal. So basically the sign will change.
Hmm.
So what is this? This is nothing but log of x base b, and I am getting that this is actually greater than 0. But in the question it's given that it's less than 0. So the first option is incorrect. Tell me if any problem occurred till this point. The first option is incorrect.
Hmm.
Now let's move on to the second part. The second part is telling me the same things. B is obviously greater than 0 but less than 1, and I have another number x. Sorry, I have another number. No, sorry. I have here also I have x is less than greater than 0 but less than 1. But here I am getting one more condition. The condition is x is actually greater than b. This is one more condition which they have added. I have to see whether log x base b is greater than 1. Now, by the same logic which I have done in previous one, I can say log b is actually less than 0 and log x is also less than 0. Now, there is one thing to understand here. How many of you know about monotonic functions? Do you people have any idea what are monotonic functions, strictly monotonic or monotonic functions? If anyone don't have an idea, they can raise their hands. Okay, okay, okay. So some of you don't know what are monotonic functions. Okay, let me draw a graph first. Let me draw a graph. Let's take an axis. Let me draw a function something like this. If I particularly take two values on this particular function, let's take one value here. It's actually, sorry, it's x1 and another value somewhere here. Let's take x2. Now along the number line, as we move from left to right, the value of x, the value increases. The value increases along this direction. So by that logic, x1 is obviously less than x2. And this height is nothing but f of x1, and this height is f of x2. We can clearly see that here f of x1 is actually less than f of x2. So in simple logic, if x1 less than x2, this implies f of x1 will be less than f of x2. Then this kind of curve where this particular phenomena occurs are called strictly monotonic curve. And what is monotonic? What is the difference between monotonic and strictly monotonic? Here we can see that the curve is strictly increasing. What I mean to say, if I take 2 points, for one point the functional value will be greater than the other, not equal. But if I have something like a straight line, I can see that x1 here, x2 here, but both the values are actually same. That is x1 less than x2. If this implies f of x1 less equal to f of x2, not strictly less, but it can be equal. If this criteria happens, then we call it as monotonic, monotone increasing. Okay, this is called monotone increasing, and you can call this as strictly monotone increasing. So this is something we know that about monotonic curve. Now the catch is logger. If you draw the curve of logarithm, if you I'm drawing with my hand only, huh? This is something how a logarithmic curve looks. Okay, so we can easily see that this kind of curves are strictly monotone increasing, strictly monotone increasing. Log function, or let me take log x. Log x are strictly monotone increasing. So why I'm actually telling you about monotone increasing? Basically, we have x greater than b. So from here I can write that log b will be actually less than log x, because it's a monotonic curve. That's why I can write it. Any doubt till this point? Am I good to go? Okay. So I have now two things. Log b is actually less than log a. Log x, sorry. I got log b less than log x. And also both log b and log x are negative, less than 0. So what I can do is I am writing it in reverse order. That is log x greater than log b. Now, if I divide both side by log b, log x by log b, what will happen? My sign will change now, log b by log b, which is nothing but 1. Why my sign changed? Because I am dividing, I am actually multiplying some number with a negative quantity.
सर
So, this is, yeah, tell me.
सर नहीं यहाँ पे log x ग्रेटर देन सॉरी log b सब फर्स्ट वाली लाइन में log b लेस देन log x ठीक है फिर उसके नीचे log x आपने ना बस पोजीशन चेंज की है एंड साइन भी और तो मेरा क्वेश्चन ये है कि आप हमेशा log b ही क्यों लेते हो हम log x के साथ तो भी तो सेम सेम चीजें कर सकते हैं आई विल
Uh,
परफॉर्म
uh,
सेम
yeah, yeah, you can do the
ऑपरेशन
same operation, but look at the question. What is actually, tell me, what is log x base b? This is nothing but log x by log b, na?
हाँ
That's why I'm taking log b at the base, nothing else.
ओके ओके ओके
That's a simple logic. Yeah, so that's why I can say that log x base b, this is actually less than 1. But in the given question, it is most probably given greater than 1. So this is why my second option is also wrong. Have you people got it? Yeah, people, if you are comfortable in Hindi also, you can tell, no issue. Hindi, English, Bengali, anything. uh, Second one is okay na? Why second option is wrong? Just give me a thumbs up that it's okay for you people. Okay, okay, I will be speaking in English, no issue with that. Okay, now let's move on to the third question, or rather, let's say third part. The third part is saying we have, obviously this is always given that b is always between 0 and 1. My uh, the b is lying always between 0 and 1. 0 less b less 1. And I have one more thing here. I have actually x which is less than y, if I am not wrong. Let's just let me check. Yeah, okay, I have these two conditions. Obviously, just as before, we can say that if I take log b, it will be strictly less than 0. And since log functions are monotone increasing, strictly monotone increasing, so I can say log x should be less than log y. Now, what I can do is I can divide both side by log b. And by same logic, since log b is a negative quantity, we are dividing is just like multiplying something with reciprocal. So I can write it as log x into, okay, multiplication won't look good here, 1 by log b. And since I am multiplying with a negative quantity, so the sign will change, and here we will have log y into 1 by log b. So ultimately this is giving me log x base b, this is actually strictly greater than log y base b. And most probably this option is correct. Yeah, this option is correct. This option is correct. That's why. And for the fourth problem is something I don't think I have to do. The most of the people, you know the properties of log, right? That is log base 10 100. This can be written as log base
सर
10.
can you repeat the option number 3 because I don't understand
This
option
one,
हाँ
the
green
logic,
color
yeah, the
हाँ
third logic was same only. What I have done in the previous two only, The logic of the third option is also same.
Okay, okay. Hmm, got it.
Okay. Now the fourth option is, I can write log 100 base 10 as log 100. 100 can be written as 10 square. Log 10 square base 10. And since we know that this will become 2 log 10 base 10. And log 10 base 10 is obviously 1. So this will ultimately become 2. And 2 is basically a rational number. Any integer can be considered as a rational number, but not a rational. You cannot consider rational numbers as integer. So the fourth option will be correct. Just tell me, people, if anyone has any kind of doubts. Okay. If I'm good to go, I'm going for the next problem. Yeah. Yeah. Let's take this one. The question is visible, right? So I have a kind of equation. I have to just solve for what will be the value of it, and most probably this kind of question you can expect in your exam from the logarithmic part. This kind of question can come. So let's do this one. We have m to the power log 2 base 3 plus 2 to the power log 3, sorry, log m base 3. This is equal to 8. Okay. Consider this to be as x, and consider this. I don't need to consider something as this. Let's consider this to be x. Why? I will be telling you. So x is equal to m to the power log 3, log 2 base 3. This. Now, how should I simplify this part? This is a big question. Now, just see one thing. I can write 8 as 2 to the power 3. 2 can be written as 2 to the power 3. 8 can be written as 2 to the power 3. So what I am doing is I am taking log on both sides, not just log. I am taking log base 2. So if I take log base 2 here, so what I will get is I will get log 3, log 2 base 3, log 2 m. This, you people are familiar with the properties of log, right? Since exams are coming, most probably you people are familiar with it. Am I good to go? Okay. Uh, Now what I can do is I can write it as log 2 by log 3, and this as log m by log 2. You can easily see that log 2 and log 2 are getting divided by each other. So ultimately this is becoming log m by log 3, which is nothing but log m base 3. Therefore ultimately we can write log 2 log x base 2 is nothing but log m base 3. And ultimately then what is x? X is nothing but 2 to the power log m base 3. This is the simplification of x. Initially x was m to the power log 2 base 3. I just simplified it to be 2 to the power log m base 3. Tell me if you people have any kind of doubt here. If anyone has a doubt, please raise their hands. Okay, so I can proceed, I hope. So now since x has been computed, I will substitute the value of x. So what I will get is 2 to the power log m base 3 plus 2 to the power, another part was 2 to the power log m base 3. This is nothing but 8. So we can see that both the terms are same. So we can write it as 2 into 2 to the power log m base 3 equal to 8. This can be simplified as 2 to the power m log m base 3 equal to 4, and 4 can be written as 2 to the power 2, right? So if I can write it as 2 to the power 2, since if we have a to the power x equals to a to the power y, if both the bases of an exponential are same, we can actually equate the powers. This will actually imply x is equal to y. By that logic, we can say that log m base 3 is nothing but 2. So ultimately, what is m? M is 3 to the power 2, which is 9. So this is the value of m. Tell me if there is any kind of doubts. Uh, if it's okay, just give me a thumbs up. Then I can proceed to the next one.
Got it, sir.
Okay, let's move on to the next question. Let's see what's waiting for us. Yeah, yeah. Uh, you have to. You are given fx as root over 9 minus x squared. You have to find the value of this particular uh, expression, limiting expression. Okay. Uh, just before beginning something, I just wanted to ask that, do you people know what is this? What is this? Any clue? This is something you people have done in your school. You have seen it somewhere.
लिमिट्स कंटिन्यूटी में लिखा था आई थिंक सो
Not
क्या
continuity. Not
लिमिट्स
continuity.
लगेंगे
It's
इफ
a limiting
एक्टिविटी
expression, obviously. But what does this particular thing means? This is the first principle of derivative. This is the this is
प्रिंसिपल
the
ऑफ
first, yeah, first principle of derivative. What when we say that a function is differentiable, if we have a function, let's say y equals to fx, we say that the function is differentiable at, let's say, any point x equal to a. If I have to check the differentiability at this point, basically we mean to check that limit x tends to a, f of x minus f of a divided by x minus a. Now this, as since you people know limit, this can be divided into two parts. One is the left hand limit, that is limit x tends to a minus, as x approaches a from its left hand side. This is the left hand limit part. This is called left hand derivative, normally denoted as LHD, fx minus f of a divided by x minus a. And there is another part which is the right hand derivative, which is as x approaches a from the right hand side, which is f of x minus f of a divided by x minus a. So this thing is nothing but this particular two things. Yeah,
there is a no it's like both left and right formula similar so there is no difference between both of formula?
No. Sometimes this can happen that the left hand derivative exists, but the right hand derivative doesn't exist. For a function to be differentiable, you have to make sure that both the left hand derivative and the right hand derivative are same. Both exist and have to be same. What does
Okay.
it mean that a derivative exists at a particular point? If we calculate this value, any let's say left hand derivative, it should give me a finite value, not an infinite value. It should give me a finite value. And if in both the cases, in case of left hand derivative and in case of right hand derivative, both the cases you are getting the same finite value, then we can say that the function is differentiable at that point. And
Okay.
this particular value is nothing but written as f dash a, or someone says this as f prime, something like that. This is first order derivative.
Okay. Okay.
So by the given question, you are given that the function is this is nothing but the differentiability is given for the function, and you are given f of x here. So in simply instead of calculating the limit, you can easily say that the given function is continuous and differentiable. To be honest, you won't be given such kind of problem. In if this kind of problems are given, you won't be given any such problem where there are the points of discontinuity in, or the function is not differentiable somewhere. This kind of functions won't be given. Okay, so you can easily consider that this given limiting value exist, this exist. Okay, so since we know that this is nothing but f dash of 2, so I can write it as root over 5 into limit x tends to 2 f of x minus f of 2 divided by x minus 2. This is nothing but root 5 into f dash 2. Now you can easily calculate f dash x. I hope you people are familiar with how to calculate derivative of a function.
Hmm.
Can I consider that fact that you people know how to calculate derivative? If anyone doesn't know how to calculate derivative using chain rule, they can please raise their hands. Okay, fine. I am considering the fact that you people know how to differentiate a function. So basically, what is f dash x? I have been sorry. First of all, let me write fx. Fx is nothing but root over 9 minus x square. So what will be f dash x? Basically, this will be 1 by 2 root over of 9 minus x square. Now applying chain rule. So I will get 0 minus 2x. So ultimately, this will give me minus x by root over of 9 minus x square. This is the derivative of the function at any point x. Now I need the derivative at the point 2. So I will be calculating f dash 2. So this will give me minus of 2 divided by root over of 9 minus 2 square. So this is becoming minus 2 divided by root 5.
Nice.
So
Hmm.
if I put this value here, this particular value, if I take an input it here, then what I will get? I will get root 5 into f dash 2, which is nothing but root 5 into minus 2 by root 5. Sorry,
Yes.
minus 2 by root 5. So ultimately this will give me minus 2.
Good answer. Hmm.
Okay, any doubt
Got it, sir.
regard?
Got it.
Okay. What about the remaining people? Hey, i- uh, if you people have any kind of doubt, you can tell. Uh, okay, let me consider the fact that most of the people don't have any doubt. Okay, now let's move on to the second this question. uh, paste it here only. Okay, let's do this question. Oh my god, 1 minute. Let me zoom out a bit. Okay, okay. In this particular question, I have to calculate the limiting value at x equals to 0. So this is kind of a straightforward question. So I have to check what is the limiting value at 0. So we know that if I have been given to find a limiting value of a function, let's say y equals to fx is some kind of function I have to calculate the limit of the given function at any point x equal to a. The definition of a limit is, I have to check it in this way, that if both the limit, one is obviously the left hand limit and my right hand limit, both of them exist and both the value are equal. Exist means the value of this limit should be finite first of all, and both the left hand and right hand limit should be equal. If this happens, we can say that the function has a limit at a point x equal to a. So here I have to check for the limit at the point x equal to 0, and according to my given function, I have been given that the function takes the value x square, it's this quadratic value when the value of x is greater equal to 0, and this exponential expression when the value of x is less than 0. So if I have to check for limit x tends to 0, I'm considering the left hand limit first, fx. So what will be this? What does x tends to 0 minus means? That x tends all those values which are less than 0. Basically, it's approaching 0 from the left hand side. If this is 0, we are approaching 0 from the left hand side. That means the values of x can take all those sequential values which are less than 0. So correspondingly, my functional value will be during that time as e to the power x square plus 3. So if I evaluate this limit, since we can easily see that this limiting value will be e to the power 0 square plus 3. So e to the power 0 plus 3, this will give me 1 plus 3 equal to 4. This is the left hand limit. And what will be my right hand limit? My right hand limit will be x tends to 0 plus fx. And according to the given function, we can write it as x square minus, what was that? 2x plus 4. So I have to calculate this value. We can easily put 0 square minus 2 into 0 plus 4. So this is also giving me 4. Therefore, we can say that limit x tends to 0 fx, this value is nothing but 4. Since both left hand and right hand limit are equal. Tell
LHS
me,
square.
tell me, any doubt?
No.
Remaining people, just give a thumbs up. Okay. Okay. So let me move to the next question. This one. I have to evaluate this limit. Okay, just tell me how many of you know about L'Hopital's rule? How many of you know about L'Hopital's rule? If someone doesn't know, please raise their hands. Then I can consider the fact that you people know about L'Hopital's rule. Okay. So here in this question, I have been given a function. Uh, Here fx is nothing but x to the power 4 minus 3x cube plus 2 divided by x to the power 4 minus 5x cube plus 3x square plus 1. I have to evaluate the limit of this given function at x equals to 1. So what I am trying to do is I am trying to evaluate limit x tends to 1 fx, which is nothing but limit x tends to 1 x to the power 4 minus 3x cube plus 2 divided by x to the power 4 minus 5x cube plus 3x square plus 1. This particular kind of problem you can solve it in any simplification manner. uh, just for the sake of simplicity I am doing is it in L'Hopital's rule only. Just now do one thing. uh, don't you people don't try to write it. Just set the value of x as 1 in your brain. You can easily see that when I put x equals to 1 I will get 1 minus 3 plus 2. So this will give me 0. And what about my denominator part? Denominator will be 1 minus 5 plus 3 plus 1, obviously 0. So I will write it as this stands for 0 by 0 form. If this kind of form takes place, according to L'Hopital's rule, what I can do is I can differentiate both numerator and denominator part till the point my denominator is actually non-zero when we put the limiting value. Till that point we will differentiate. So doing the first differentiation, this will give me 4x cube minus 9x square plus 2, sorry, not plus 2, divided by 4x cube minus 15x square plus 6x. Now just by what we have done previously in the same logic, just put x equals to 1 in your head. You will get 4 minus 9, which is minus 5. And
Minus
here
5.
if we put the value in the denominator part, we will get it as minus 5. We can clearly see that the value is not becoming 0 by 0. So now we
Yeah.
can easily put the limit. So it will be 4 into 1 cube minus 9 into 1 square divided by 4 into 1 cube minus 15 into 1 square plus 6 into 1. So ultimately what we have find that this will give me minus 5 divided by minus 5. So ultimately this value will be 1. So this
Mm,
limiting value will be 1.
mm.
Is it okay for everyone? Okay. Okay. Let's move on to the next part. Let's take this one. Okay. You have to calculate this limit. Now, when we are say to find the limit of a sequence, normally if it's not mentioned, basically they are asking you to calculate limit n tends to infinity a n. This particular value they are asking you to calculate. So for the given problem, I will uh, I will write an algebraic expression, not an algebraic expression, a sum, a sum. Okay. First particular sum that you people need to remember comes in handy. That is 1 plus 2 plus 3 plus, if I take the sum of n natural numbers, this is actually equals to n into n plus 1 by 2. The second one
mm,
is 1 square plus 2 square plus 3 square up to, if I take this sum up to n square, this value will be n into n plus 1 into 2n plus 1 by 6. This is something you people might have done in your school also.
mm.
The third is 1
Yes.
cube plus 2 cube plus 3 cube. Ultimately, n cube, this sum will basically give you n into n plus 1 divided by 2, this square. So these are three. I would say it's better to remember this series. It comes handy during calculation. So I have been given here a n as 6 plus 6 into 2 square plus 6 into 3 square plus 6 into n square divided by root over of n to the power 6 plus 5. Therefore, if I take the limit as n tend to infinity a n, this will basically give me this limit 6 plus 6 into 2 square plus 6 into 3 square, this series divided by root over n to the power 6 plus 5, this one. Now what we can do is we can take 6 as common, and since it is a constant value, we can bring it out of the limit, just like in case of derivative, what we do as function of, when we try to differentiate a function like this ddx of cx, we take c as a constant and put it outside the operator of derivative. So in the same
Mm,
logic, what we can do is we can take the 6 out and we can write limit n tends to infinity, this is becoming 1. Now 1 can be written as 1 square, no issue. 2 square plus up to n square, this particular thing is divided by root over n to the power 6 plus 5. Now as I have written, I can write it as limit n tends to infinity, this can be written as n into n plus 1 into 2n plus 1 by 6, this total divided by root over of n to the power 6 plus 5. Now here we can see that again we have 1 by 6 as a constant and we have another constant 6 outside. So I can easily, let's say, cancel out 6 and 1 by 6. So this will ultimately give me limit n tends to infinity n into n plus 1 into 2n plus 1 divided by n to the power 6 plus 5. Now here is one part. Now tell me one thing. In the numerator portion, what is the? It's a polynomial of degree 3, right? Can I say the numerator has a polynomial of degree 3? It's a polynomial. It's a cubic expression.
yes.
The highest power of n will be 3, na? Numerator part. If you people are not getting, please tell me. Okay, okay. And what about the denominator part? Now denominator has n to the power 6. So it's a polynomial of 6 degree. But there is one more thing here. We have a root over. Just in a
Under.
naive sense, think n to the power 6 to the power half. So basically here we also
Yeah.
have a polynomial of degree 3 in the
Yeah.
denominator part. So what we will do is we will divide both numerator and denominator by n cube. So I can write n into n plus 1 into 2n plus 1 divided by n cube. This totality can be divided by root over n to the power 6 plus 5 divided by n cube. I can write it now. This can be written as limit n tends to infinity. 1n cancels with 1n, and if I take 1n inside the okay, let me write n plus 1 divided by n into 2n plus 1 divided by n. I have just separated 2n square. I have taken one as a factor dividing n plus 1, and another one dividing 2n plus 1. And in the same logic, I am doing inside the root over. I am taking the entire root over and I am converting n cube as n to the power 6. I am converting it to the n to the power 6. I have taken the entire root over. Since we can easily write a as root over of a square, provided a is greater than 0. Otherwise, we can't write. Now, just now we need to do some simplification, which will give me 1 by 1 plus 1 by n, and this will give me 2 plus 1 by n divided by root over of 1 plus 5 by n to the power 6. Now, here comes the tricky part. If n tends to infinity, then 1 by n tends to what? Tell me. If n tends to infinity, then 1 by n tends to what? Yeah, correct. See, if n is a number which is sufficiently large, and if I divide 1 by any number which is sufficiently large, let's say just a sake of example, if I divide 1 by 50, the value will be, the kind of value I will get will be strictly greater than the number I will get after dividing 1 by 5,000. Obviously, soon as we try go on increasing the value of the denominator, the number will become smaller and smaller. And if we make the denominator sufficiently small, then the particular number will become very, very small, as if it is close to 0. So that's why if I take this limiting value and just put the limiting value here now, I will get 1 plus 0. Here I will get 2 plus 0 divided by root over of uh, just 1 minute. Is it have I written the question correct? Oh no, sorry. I have made a mistake. It's actually here we have a 4. Here we have a 4. I actually neglected that. 4. So this will be 4 plus 5 by 6 to the power n. So this will give me 4 plus 0. Obviously, if 1 by 10 n tends to 0, then 1 by n to the power 6, this will go faster towards 0. Both will tend to 0, but uh, let's say the speed of convergence will be higher for 1 by n to the power 6. So this will ultimately give me 2 by 2 equals to 1. So this limiting value will also be 1. Tell me if there is any problem or doubt with this problem. Anyone? Any issue? Just give me a thumbs up, then I can move on to the next problem. Okay. Yeah. Well, I joined the session late, so any uh, which week is going on? It's not actually week wise it's going. I am actually solving a question paper. Most probably it's from I don't remember. Yeah, quiz to questions. Any previous term question. I don't remember which one. Okay. Now let's do the this one also. Okay. So I have to calculate the limit of this given sequence. And since in the previous one also I have told you, if you are asked to calculate the limit of a sequence, they are basically asking you to find this limit. That is limit n tends to infinity an. This limit you are actually asked to calculate. So let's solve this question. Here we have an equals to 100 n square minus 11 divided by 100 n cube plus 7. So I have to calculate limit n tends to infinity an. So which is nothing but limit n tends to infinity 100 n square minus 11 divided by 100 n cube plus 7. Here the numerator is a quadratic. Uh, we have n to the power 2, highest degree polynomial term of 2, and the denominator have n to the power 3. So what we will do is we will divide both side, both numerator and denominator by n cube. Why? In most of the cases we divided by the highest power. So I will get limit n tends to infinity. This will become 100 n square minus 11 divided by n cube. Total divided by 100 n cube plus 7 divided by n cube. See, there is something I want to tell you people. If you people are comfortable with L'Hopital rule, you can also use that. It won't be any issue. Just you need to do one quick substitution. That is, you have to take n as 1 by x. Now as n tends to infinity, 1 by then x will tend to 0. You just need to make one particular substitution, and then you will find that it will take 0 by 0 form, and then how you proceed for L'Hopital's rule you can do that. But I particularly find this technique easy for myself, so that's why I am doing this in this particular way. I am dividing both side by n cube. So I will get limit n tends to infinity. I will get here 100 by n minus 11 by n cube divided by 100 plus 7 by n cube. Now by the previous one also, now as n tends to infinity, 1 by n will tend to 0. By same logic, 1 by n cube will go rapidly towards 0. So this will make this value 0. 100 into 0 minus 11 into 0 divided by 100 plus 7 into 0. So ultimately this value will be 0 because the numerator is becoming 0. But you before putting the value of limit, you have to make sure it's not actually becoming infinity. If it becomes infinity, you have to make sure that you are doing that sum in a correct way. Tell me if this problem has any, if you people have any doubt with this problem. It's okay for everyone. Just give a thumbs up. Yeah, you people have decided that you won't speak. Okay. Let's move on to next questions. Okay, this graphical question. Let's do it here only. I will do the remaining part there. Just tell me if the question is visible. Okay, you people just give me a thumbs up that the question is visible. Okay. So, in this particular question, you can see that there are actually one, two, three, four curves given. Now, according to the given curves, there are particular questions you have to select which one is correct. Now, for curve 1, it's given that there are at least 2 points between -4 and 4 where the derivative of a function corresponding to the curve 1 are equal. Now, what does mean that the at a particular point the derivatives are equal? Uh, we know that derivative of a function at any point, what does it give us? It gives us a slope of the tangent. It gives us the slope of the tangent. So in order to make sure that the derivatives are same, then we should have the slopes of those particular curves are same. Or to be very precise here, I have to check for the tangents where the slopes are same. From the given curve, I'm actually drawing on the curve only. We can easily see that if I draw a tangent at this point, it will be parallel to x-axis, right? By same logic, if I draw another tangent at this point, it will be also parallel to x-axis. Here also I will find a tangent which is parallel to x-axis, and here also tangent parallel to x-axis. Now all the tangents which are parallel to x-axis will have slope 0. So according to the given question, it's saying that between -4 and 4 there is at least 2 points where the derivatives of the functions corresponding to curve 1 are equal. So we can see that there are actually more than 2 points. This one, this one, this one, and this one. In this particular places, we can see that the derivatives are actually same. All the derivatives will vanish in this particular places. So here it is given at least 2. So the given option should be correct. Tell me if you people got this or not. Why the first option is correct. Now moving on to the second part. At the origin, the derivative of the function corresponding to curve 2 does not exist. So if I see the curve 2, now let me tell you something. If you see a curve where the function is something like pointy, the graph of the function is pointy, something like this, something like this, we can easily say that at these particular points the derivatives won't exist. Why the derivatives won't exist? Because the functions won't be differentiable at those points. Now why those functions won't be differentiable? uh, let's say in those particular point the function will have more than one tangents. That's why, since tangent at a for a curve should be well defined, and if a particular point has more than one tangent, then on all those points we can say that the derivative or the function is not differentiable. So we can see that in this curve there are pointy edges. This is a pointy edge. So if I consider the derivative as at this point, the derivative of this at this point won't exist. So according to it, the second option should be correct. So at the origin, the derivative of the curve should not exist. Just tell me if it's clear or not. Just give a thumbs up. Okay. Let's moving on to the third question. The derivative of the function corresponding to curve 3 at the origin and point minus 2 comma 0 are equal. So this is minus 2 comma 0 point. So if I draw a tangent, roughly speaking, the tangent will be like this. And if I draw a tangent at the origin, since the origin we can easily see that the origin is a point of minima. So the tangent will be parallel to x-axis, or rather let's say the x-axis is the tangent. We can easily see that both the tangents are different. So the second or the third option shouldn't be correct. I hope it's clear why this option is wrong. Give a thumbs up if it's clear. What about the others? Yeah, am I? What should I say? You people feeling bored? Uh, just tell me if there is any issue, any kind of problem. You can write it in the chat box also if you are not getting something. Okay, I think. Okay, let's move on to the next part. The derivative of a function corresponding to curve 4 doesn't exist at the point. Now, honestly speaking, I myself can't see any curve. I am not actually seeing any curve. If there is something, I don't know. I have taken this question from a question paper. I don't know if they had given any curve here or not, but from the uh, given figure, I can't figure out where is the curve. So I won't be talking anything about the last option because I can't find the curve actually. I don't know. Can you people see any kind of curve which I am missing? Because in the diagram, most probably I am not getting any kind of curve. Should I move on to the next question? It's parallel to x-axis. It's parallel to x-axis. Where? Which one? At 0 comma. Okay, 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 okay. Got it. My God. Let me just draw it first. 0 to this one. So this is the curve. The derivative of the function corresponding to curve 4 doesn't exist at any point. No, it's actually wrong. The derivative exists, and any line which is parallel to x-axis have a derivative 0. So if a line is parallel to x-axis, it will always have a derivative 0, or rather say the slope of this curve will be 0. But however, there is one catch. If the curve was perpendicular to x-axis, let's say the curve was like this, then we can say that the derivative of this particular curve don't exist. It won't exist. For this one, it won't exist. For this one, it's actually 0. So the fourth option is also wrong. Tell me if it's clear or not. Yeah. Okay. Now moving on to the next part. This one I had done. Okay. Now this question. Okay. Let me take one more page. So I have been given a function. The function is something like this. Let me write down the function first. So I have been given a function like this. Fx equal to, this is box of x plus 1 when the value of x is greater than equal to minus 3 but less than 0. The value of fx is 0 when x equal to 0, and curly bracket x plus 1 when x is actually greater than 0 but less equal to 3. This is the function given. Now what is box function and what is curly braces, they have defined. Here the box is actually defined as greatest integer function, and the curly brace was defined as fractional part function. And the remaining hint has been given in the question. Still, for the sake of completion, I am writing it. Let's say you have a box of 1.35. This box will result into 1. If the number is negative, let's say minus 2.39, then this will result in minus 3. And in case of integer, let's say we have integer, for example minus 5. So in this case also it will give me minus 5. Any kind of integer I will get it as it is. But if there is any kind of real number which is positive or negative, there will be certain changes. Second one. No, 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 no. No, no, it won't be. Because in this case, what happens, when the value is negative, it basically takes what? It takes the minus 2 and it adds a minus 1 to it. So it becomes minus 3. For any positive number, it takes the integer part. For any negative real number, it takes the negative integer parts, adds a minus 1 to it. Let see this one. Here we have minus 1.32. Minus 1.32. It's actually taking minus 1 and adding one negative 1 to it. So it's becoming minus 2. Have you got it? Did you understood what happens? For positive number, it's okay. For positive real number, it's taking the integer part. But not for the negative one. It's the speciality of box function. Then for it, for minus 5 it's minus 5. Yeah, for integer values it will remain as it is. Not, it will only change for let's say real number values. Now real number contains negative values and positive values. For any particular integer it will behave as it is, but for any negative real number it will take the integer part and add a minus 1 to it, and for a positive real number it will just give me the integer part of it. Now if you people have, okay, any doubt regarding box function, this box function is also called a step function or greatest integer function. Some people call it ceiling or floor, I don't remember. Most probably ceiling function. I'm sorry, floor function it will be. It has many names. And let's move on to the next part. The next part is a fractional part. Now what does fractional part do? The fractional part behaves somewhat in the same way. For example, if I have an integer value, let's say I have here 8. It will take the integer and it will give me as it is. It will give me the same value. But if I take any value which is a real number, for example, if I take 8.000001, it will just give me the output of 0.00001. Just taking the fractional part. When there is a fraction, it will give me the fractional part. When it's an integer, it will give me the integer part. Same goes for negative number also, minus 2.33. It will just give me minus 0.33. Tell me if there is any kind of doubt. These particular things will be given, are given as a hint. Sorry. I made a mistake. It if it's integer value, it's give a 0. Okay, here, see, if it takes integer, the fractional value will be 0, the fractional part. Other than that, it will return the fractional part. Tell me if up to this point it's clear or not. Okay. Now, if I have to draw the graph of this particular function, this functions has some peculiar specialities. I would say these are peculiar because this kind of functions have jump discontinuity. Let me draw the curve, you will understand why. I will be drawing a rough sketch, okay? It won't be up to mark because let's say this is origin 1, 2, 3. I'm taking up to 3, and in this direction I'm taking minus 1, minus 2. So particularly for 0, the value of my step function will be 0. Okay. Now any value greater than 0, less than 1 will be around this range only. Sorry, if it's not visible, let me just increase its size. Up to from 0 to till the point that is touching 1, this value will be 0. But at the point 1, what is f of 1? When it's a box function, its value will be 1. So we can see that it will form a hole here. What kind of hole? Here the value will be missing and it will take a jump, and the value will be here. For 1, the value is 1. For 1, the value is 1. Now for any value which is greater than 1, less than 2, it will remain on the same base, like this only. It will move forward till point 2, till point 2. Now when at 2, it will again make a jump. It will make a jump again of height 2. Here the function's actual value will be here. This is 2. In the same way this will go on. I hope the figure is clear. Why it's called step function? It looks like a stair. That sometime it's called a step function. Is it clear to everyone? Why? What is the graph of greatest integer function or box function? Just give me a thumbs up. I have seen this graph. Yeah, you people might have seen this graph in, uh, most probably if you are familiar with probability, there is a term called probability mass function, PMF. This is which is nothing but those are step functions. Now in this particular case, the step functions look like this. It might happen that the step function might be like this also, like this, then here we have a point, then like this. So it can be of many shapes, but this is the simplest one. This step function is the simplest one. So this is my box function. Now this is the graph of fx equals to box x. Now what about the graph of fractional part. What is the graph of fractional part? Now let's draw that one also. Fractional part. Okay. Let me take only positive x-axis. It will be easy to draw. Okay. Just tell me one thing. What is the range of fractional part? What will be its range? Its range is simple. No, not 0 to 2. It's 0 to 1. 0 to 1. Imagine. Just see. When I am getting 1.999, it will give me 0.999. 0.999. When it's becoming 2, it will give me instantly 0. So basically my fractional part, the value of my fractional part is lying in the range from 0 to 1. Its minimum value is 0 and its maximum value that it can attend is 1. Now let's draw. Let's say here we have 1, here we have 2, and we have 3. Let's make for this part only. Let's take, okay. Now let's say this is up to this range, it's 0 to 1. Let's say this is the upper range. Okay. The graph won't be up to mark. Still I will try. Let's say this is 0 and this is 1. Okay. Now when my value is lying between 0 and 1, it's increasing. For 0 it's 0. Now when it's increasing from 0 to 0.1, it's becoming zero point 0.1. So ultimately it's going up till the point, when it becomes close to 1. Now when it becomes 1, here we are forming a hole, and the function is getting defined at this point. Let me make it clear. Okay. Here the functional value exists here. Now from 1, let's say 1.01, the value is increasing to 0 0.1, then 0 0.2, 10, increasing up to this point. When it's becoming 2 again, it's forming a hole here and it's getting defined at this point. So the graph of this function will be something like this. If it's just give me a thumbs up if it's clear. Just give me a thumbs up. This is the graph of the function. Now why did I bother drawing this kind of curve? Because there is something important happening here. The first thing you can see that if you calculate what is continuity, if I had to calculate the continuity of this function at the point 1, let's say limit x tends to 1 minus fx, what will be the value here? Its value will be 0, because x is approaching 1. That means the value of x is less than 1, and for less than 1 the box function will give me 0. Now what is happening, if we take limit x tends to 1 plus, tell me, when the value of fx is greater than 1 plus, then what's happening? The value of fx is becoming 1 now, because x is approaching from the right hand side. From the right hand side, that means the value of x is slightly greater than 1. Now slightly greater than 1, let's say 1.001. Still for that my box function will give me 1. So we can clearly see that at this integral points my function is not continuous. Please tell me if you got this point or not. It's important for this problem that the functions have discontinuity at the integer points only at integer points. You can take any integer, 0, 1, 2, any integer. You can check the limiting definition. You will find that both the limit exist, but both the limits are not equal. Since both the limits are not equal, there is no question of continuity. Tell me if it's clear or not. uh, Anyone? Am I audible, right? If you people have any doubt, please tell me, because this is something important that will be needed for this problem only. Okay. I from my side, I am hoping that you people are getting what I am trying to say. So the conclusion is basically box functions, box function are discontinuous at integer points. Or let's say what kind of discontinuity this is. It's jump discontinuity. It's making a jump. It's making a jump every time, because the definition, according to the definition, the functional value, if I take f of 1, this value will be 1. So it's making a jump. So this is called jump discontinuity. Now let's move on to the fractional function. You can, by the same logic, you can see that the same thing is happening here also. From the graph we can see that the function is here also making a jump. If we calculate limit x tends to 1 minus fx, this is for the fractional part. 1 minus means the number is actually slightly less than 1, slightly. So that can be considered to be as lying in particularly this range. This will give me that particular value. For example, if I have 0.9999, let's say 15, 50 times 9 I am repeating, then a 1, then the value will be that only. But when I say limit x tends to 1 plus fx, in that case the value won't match. In fact, even if that also matches, let's say I am taking the value of, since it's approaching from the left hand side, I am taking the value very very close to 2. Let's say I am taking x as 2.9999, the same value. So it will be equal. But what about f of 1? For f of 1, I will get it to be 0. So even if my left hand and right hand limit are same, then also I can guarantee it that my functional value won't be same. So in this case also we can easily see that the integer points, at the integer point the functional value doesn't exist. Or rather, let's say the function is not continuous at integer points. So the fractional part are not continuous at integer parts. Okay. So this was the intro, let's say outward idea what's happening here, what kind of functions we are dealing with. Now let's move on to the question. Okay, the question is on the other page. Okay. Okay. tell me, here it's given us true and false. We have to check that the left hand limit and right hand limit of a given function exist at x equal to 0. I have to check whether at 0 point the left hand and right hand limit exist. So what will be my left hand limit? Limit x tends to 0 minus fx. Now when I am taking fx to be uh, my x to be approaching from the left hand side, what is the value of fx when x is less than 0? This is nothing but limit x tends to 0 minus this particular box of x plus 1, this value. Now tell me, for any value which is little bit less than 0, little bit less than 0 means let's say minus, that number will be negative. Now if we subtract very small number from 1 also, the this particular value will be 0 point something, and if we take that particular number and perform the box function, this value will be 0. Tell me if you understood this or not. Any questions or any problem? Since x is less than 0, we are subtracting a small number from 1. So the ultimate result will be 0 point some number, and we have seen that the box function of 0 point something will give me 0. By same logic, if we consider the right hand limit x tends to 0 plus fx, what I am getting, since x is greater than 0, this time I will take the fractional part, that will be x plus 1. Now if I put here 0, the value of x is very slightly greater than 0, slightly. Okay, now if I put the limiting condition here, almost the value, this value will be almost equal to 1 na? And when I am getting 1, since we are calculating limit, that means x is actually tending to 0 from the right hand side, but x is not actually equal to 0. But when we calculate the limit, we actually put the value as 0 plus 1, so this will ultimately give me 0. This is the rule of calculating limit, right? When we calculate limit, we just see that if we put the particular value, it's not causing any kind of 0 by 0 form or infinity by infinity or 1 by 1 to the power infinity, some this kind of form is not coming. I can easily put the value of the limit, and if I put the value of the limit as 0 here, I will get fractional part of 1, which is obviously 0. So I am seeing that both the left hand limit and right hand limit is giving me 0 here. So according to this question, state true and false if the left hand limit and right hand limit of the given function exist at and are equal to each other. Since we have seen that limit x tends to 0 minus fx is equal to limit x tends to 0 plus fx. So this option should be correct. Tell me if you people have any doubt. No doubt. Or let's be honest. Are you people getting what I'm trying to say? Just tell me, someone. Okay, you got confused in the box one. See, just when you get confused, just imagine putting a small number. Small number. Since I'm telling that x is very close to zero. X is very close to zero. But x is not zero. Very close. So if I take a small number and which is actually slightly negative because x is approaching from the left hand side, when we approach 0 from the left hand side, the number we are getting must be little bit negative only. It's not 0, it should be negative. Now if I subtract any small number from 1, because ultimately x plus 1, x is a negative number, as much small as I can think of, still 1 minus a negative number. So we do not take x equals to 0 in that case. No. Box, in case of box function, don't put 0, because if you put 0 directly, you will get 1. If you put 0 directly there, what is the meaning of limit? The meaning of limit is simple, that when a function, what is the functional value approaching to when x is approaching a certain value, right? This is the definition of limit. Yeah, that's why. But why we put the value in case of fractional part? See, here comes the tricky part. When we are talking about fractional part, the fractional part can be, let's say, like this also. I'm approaching 0 from the positive side. Let's say 0.001. This is also okay. What about someone takes 0.0001? Then he will say that I am taking this value. Then this is also okay. So in that sense, if we try to think, then it will get difficult. That if someone comes and say, I will put 20 zeros here. Let's say I'm putting 20 zero, and after that I'm putting 1. This is still a number, a finite number, which is greater than 0. Still it's a finite number. And what does tending to 0 means? Tending to 0 means that if we have the ability to imagine any kind of number which is as close at it as that number particular, it can be smaller than that. It can be smaller than that. So that's why it's a concept. It's not about mathematics here. No mathematics is happening till now. It's a concept. When we try to, even this kind of concepts are used in polynomials also. When you are given a limit to calculate, like this limit x tends to, let's say, 2, x square minus 4 by x minus 2, did you, what we do is we basically simplify this. How? We write x minus 2 into x plus 2 divided by x minus 2. Now, if x is equal to 2, then this function becomes undefined, right? But since x is tending to 2, x, the value of x is not equal to 2, that's why I can cancel both numerator and denominator. Other than that, I couldn't have cancelled. Even I couldn't have cancelled, because the function wouldn't have been defined at that point. We can clearly see that if we consider a function as x square minus 4 by x minus 2, this function is undefined at x equals to 2. So in this case also, when we calculate the limit, we just put the value. Now there is no kind of issue, so we can put 2 plus 2. So basically we can say that if this is the curve, let's say this is the curve, and this is, let's say, the point 2, the function is undefined at that point. So that's why there is a hole. The function is undefined at that point. But as we approach this value, the functional value will approach to 4. This is the limit. This is what limit is. I think, am I able to make you clear why I can put the value there? Limit is a concept. Limit is nothing but a concept. So here we can clearly see that both the values are becoming 0 when we are taking the limit in both the cases. So it's becoming 0, so the first option is correct. Still, if any people here have doubt, any kind of doubt, so can I consider the fact that you people don't have any doubts? Okay. Now, honestly, if I was in your place now, I would have Many kinds of doubt till this point. Okay, let's move on to the next part. The next part is this one. Okay. Okay. The statement is true and false. The function fx is continuous at x equals to 0. Now only we have seen that limit x tends to 0 minus fx is basically equals to limit x tends to 0 plus fx. Now for continuity there is one more condition. Is this particular thing equal to f of 0? This is the question. If this particular condition holds, then we can say that the function is continuous. Now let's just check what is the functional value at 0. Now we can see that here fx is 0 when x equal to 0. Okay, let me just change the color of the pen. Yeah, this one. We can see that the value of fx is 0 when x equals to 0. So basically we can say that f of x equal to 0 when x equals to 0. So combining these two things and this one also, we can write that limit x tends to 0 fx, this is equal to f of 0, and this is the condition for continuity. So this implies f is continuous at x equal to 0. Tell me, uh, if you people have any doubt, this one, any doubt? uh, okay, just tell me one thing. Are you people comfortable in Hindi, Bengali, anything? Because since there are very less participants, I can but the box function, the graph breaks. See, the graph breaks. You have said something correct, but look at this. We have defined the function in such a way. See, have you heard this term that jump discontinuity or finite discontinuity can be removed? If we redefine a function, finite discontinuities can be removed, but not infinite discontinuity. For example, if a functional value tends to infinity as x tends to some particular value, that kind of discontinuity if occurs, we can't remove that kind of discontinuity. But if there is a certain kind of discontinuity, let's say finite discontinuity or a jump discontinuity, we can remove it by redefining the function. And if you see that how fx is defined, you can see that fx is the range of x is broken at the point 0. At when x is less than 0, the function is defined in a certain way. When x is equal to 0, the function is defined in another way. When x is greater than 0, the function is defined in another way. So there is a some sort of redefining of function happening here. That's why at the point 0, since I have redefined the function, had it been a only box function here, we can say that it should be discontinuous at the point 0. But since here is some kind of redefining happening in this particular function, so we can say that it's possible. And by the by the sum also, we saw that both the limiting values are becoming equal to 0 and the functional values are becoming 0 at that point. So continuity is explained. So if the range is given somewhat infinity, then it wouldn't be true. Range is somewhat not range infinity. For example, if a point has a infinite discontinuity, for example, let's say 1 by x. If I take a function as 1 by x, we can clearly see that 1 by x has a infinite discontinuity. No matter how, in which way you approach 1 by x, from left hand side or right hand side, the value of 1 by x will tend to infinity. This is a kind of infinite discontinuity. This kind of discontinuity is quite difficult to remove. I don't know if this can be removed. But if you have a finite discontinuity, we can redefine a function and make sure that after redefining the function becomes continuous. Is this clear? I know I'm touching some kind of concepts that might not be present in this. Let's say they might not have that might not have been discussed. For example, what is jump discontinuity? This kind of concept, most probably these are not told here. But yeah, these are few things. If you know about, you will have a better clarity what's happening. Yeah, I know that. It's not your fault. It's I you have to focus mainly on live sessions. See, the live sessions are mainly the lectures. You have to uh, do more live session. If not possible, if you can't attend live session, then please do see the recordings. That will make most of your doubts clear. Okay, let's move on to the next part. Okay, this was the question for which I told so many things. I had to draw the entire figure. So this is the question. Find the total number of points in which this particular function is not continuous. This particular function is not continuous at which points? In this closed interval minus 3 comma 3, the function is discontinuous at which points? See, initially what I told, that if the function has discontinuity, it will be only at the integral points, the integer values. Now, between minus 3 and 3, what are the integer values? I have minus 3, minus 2, minus 1, 0, 1, 2, 3. These are the values. Okay. Now we have seen that at the point 0, at this point the function is continuous. This is because of redefining of that function. Now minus 3 is an extreme point and 3 is another right extreme point. Obviously, at minus 2 the function will be discontinuous, at minus 1 the function will be discontinuous. 1, 2. These 4 points I am sure that they are discontinuous, because the range of the function has only been broken only at 0 point. Other than 0, there is no place where the function has been redefined. Can you understand this? There has been no other points where the function has been redefined. So obviously the remaining points are under my scrutiny. I have to check whether uh, I have to check the just the extreme point, that is minus 3 and plus 3. Except these 2 points, I am sure that minus 2, minus 1, 1, 2. These 4 points are sure my points of discontinuity. Have you understood this part? Why I am sure that these 4 points are discontinuous? For sure. Now let's check for two extreme points. One is minus 3 and one is plus 3. So I will check for minus 3. I will first check for minus 3. Now, since minus 3 is the extreme left point, and tell me, if minus 3 is the extreme left point in my domain, can I approach minus 3 from left hand side? Obviously, no. Because if x tends to minus 3 from left hand side, it might take some values which are for which the function might not be defined also. So that's why left hand limit is out of question here. Tell me if you got this point or not. Why I can't take left hand limit in this case? So in this particular case, I have to check for only right hand limit, and if my right hand limit has the same functional value, m- then I can say that the for particular point the given function is continuous. So I will first of all check for limit x tends to minus 3 plus. That means I am approaching minus 3 from the left hand side. From this side I can approach, but not from the right hand side. Sorry, not from the left hand side. From this side I can't approach. So from this side, if I approach this, I will get limit x tends to 3 minus 3 plus. What is the value, functional value? My functional value will be, according to the definition, it will be box x plus 1. Box of x plus 1. Now tell me, if I am taking any value which is slightly greater than minus 3, slightly greater than minus 3, any value which is slightly greater than minus 3. Obviously, if minus 3 is here, any number which is slightly greater than minus 3 will be here only. So let's take minus 2.98. Obviously it's greater than minus 3. So if I add it with 1, I will, what's the value I am getting? I will get uh, uh, here minus 2. I can break it and write, it can be written as minus 2.00 minus 0.98 plus 1. So this will give me minus 1 minus 0.98. So it will give me minus 1.98. So what will be the value in this particular case? This value will be minus 1 minus 1. So this value will be minus 2. Tell me, have you got this, why this value is becoming minus 2? By the definition only. I haven't done anything else. uh, any doubt? Have you got this, why it's minus 2? Yeah. Okay. So now I have to check for the functional value. What is f of minus 3? It will be box of minus 3 plus 1. This is becoming minus 2. Box of minus 2, when it's integer, it will give me an integer. So I can clearly see that my limiting value of as x tends to minus 3 plus fx, this is actually equal to f of minus 3. So this particular thing is ensuring that this function is continuous. Here no question for left hand limit because my function can't approach it from the left hand side. So I am just I am ensuring that my right hand side limit is basically equal to my functional value. Since this is happening, I can say that the function is continuous at this particular point. Clear? Why at x equals to minus 3 the function is continuous? Okay. So it is continuous at this point. Now I have to check for another extreme value, that is 3. Now check for 3. Now check for 3. Now how I can check for 3? The logic is simple. In this case, I won't be approaching 3 from the right hand side because I have a barrier on the right hand side. So I can't be approaching 3 from the right hand side. All I can do is I can approach 3 from the left hand side. That means I can calculate limit x tends to 3 minus fx. This particular value. And when fx approaches 3, what is the functional value here? It's actually fractional part of x plus 1. This is equal to limit x tends to 3 minus fractional part of 3. Sorry, x plus 1. This one. Now if I put 3 here. So I will get 3 plus 1. Basically, it's giving me 4. And ultimately, we know that when we consider integer, so the output should always be 0. And what about the functional value at, sorry. Just 1 minute. Uh, Taking limit as it tends to minus 3 minus means the value should be, this limiting value is giving me 0. And what for the other part? And what is the functional value at 3? The 3 at the point 3 it should be 0. Certainly it's becoming continuous here. Yeah, okay. So what is f of 3 here? So f of 3 will be 3 plus 1. This is actually giving me fractional part of 4, which is 0. So I am getting the limiting value here as both of them are same. So that is limit x tends to 3 plus fx, sorry, not 3 plus, it's 3 minus fx is equal to f of 3. So this is also implying that at this point the function is continuous. So ultimately we can see that the only points of discontinuity are only points of discontinuity. Minus 2, minus 1, not 0, 1, 2. So there are only 4 points of discontinuity. Okay, tell me if you have any doubts. Is it clear? See, I had to check for the extreme points just in order to make sure that I am doing the problem in a correct way. The interior points will be okay. The interior point, there is no redefining of function, there is no break point. So all those points will be the points of discontinuity by simple approach. That is, both the functions have jump discontinuity. That's why those integral points will have points of discontinuity. But I have to make sure that the extreme points also have some kind of discontinuity. Just tell me if it's clear or not. So there are 4 points of discontinuity. And now, so I think the entire question paper is complete. So yeah, this is all from my side. I hope you people, not you people, I hope you all have understood what I'm trying to explain here. It's only a quiz question paper. I will ask you people to just practice all the question in a good way and hope that you people get a good score. So that's it from my side. If you have any doubts, feel free to ask. I'm stopping the recording. Okay. Yeah. Welcome. Uh, Hope you people have understood what I have explained. I have tried my best that you people get what I'm trying to say. Yeah. So uh, I hope there is no doubts. So I'm ending the session here. So thank you everyone. Yeah, you have. Oh, you have attended live session, previous one also. Nice. I, by the way, are you Bengali? because title, from the title I am guessing just that. Okay, okay, okay. I can understand. I mean, Assamese and West Bengal people have somewhat close kind of titles. Yes, yes, I can understand. I can understand that part. Okay, so thank you from my side. I hope you do good in quiz 2 also. Chalo. Okay, good night. Thank you.